Hello and welcome back to Cardiac Geospatial Solutions. So this tutorial forms a new series. So in this tutorial series, we're going to work on the R software. So this software R is basically used to do some statistical analysis. So we're going to work on this from a geospatial perspective. But as a starter, in this video, we're going to work on the descriptive statistical part using the R software. So what do you mean by this descriptive statistical part? It means we're going to plot some basic charts using some basic data sets which we have. Say for instance like a bar chart, a pie chart, scatter plot, etc. So this tutorial is a very basic starting point. So from this we are going to work on many more from a geospatial perspective. Right. So let's get started. So first of all, let us see how to install the R software. Installing the R software is very simple. So you just have to go to internet browser. So just type in like download R Studio. So you'll be getting this. You have to go to this website. Pause it. So you can see that it will be showing us two download options here. So first one is install R, and the second one is install R Studio. So first of all, you have to install this basic version of R, and then you have to install this R Studio. So you can't install R Studio directly. So first you have to install R, and then only you'll be able to install the R Studio software. So first of all, let us understand the difference between these two software. So first, let us explore about R. So as you can see, I've installed the basic version of R here. So this icon of this R software. So should I open this, you'll be able to see the R console there. So this is the R console. So it is an interactive window. So by the term interactive window, you can understand that this will be giving us the output as soon as we run and execute the input then and there. Whereas in the case of a script file, you have to write the lines of code as a whole file. So for that, you have to just go to this file and then go to this option called new script. So you'll be given a window like this. So in this window, you can just type in and then you can just type in all the commands and then execute it on the whole. But whereas in the case of an interactive window, you can just directly type in the input, and then you'll be able to get the output then and there. Say for instance, if I'm doing some sort of a mathematical operation like this, 6 multiplied by 2, should I press enter, you'll be getting a result then and there. So this is the difference between an interactive window and a script file, right? This is all about the R software. So I'm going to access the R Studio software from a start window. So you can see it has been stored inside this. This is the icon of this R Studio application. So you can just access it. It will be taking some time to open Studio software. So you can see the difference between them from the display itself. You can see that it is offering many tutorials here. So you can learn all those display words. Go to this start tutorial option. So you'll be getting the step-by-step guides for many basic operations. So first of all, before doing this, you have to install some packages. So it will be prompting you to install some packages as soon as you install the RStudio software. So after that, you can just glance over these different tutorials. It will be acting as a guide for you to get started with this software. And further, you can also get the help option here. You can get the help option here. So this can also be used to find the syntax for many different. It will be guiding you how to use the syntax. What are the required parameters for a single function, etc. So these are some of the key differences between an R and an R Studio software. So creating the charts. Before that. First, let me show you the dataset which I am going to use for creation of these charts. So in this tutorial, I'm going to use only two datasets. One is stored as a CSV file, and the other one as the Excel file. So first of all, I'm going to import these two data sets into my R console, and then I'm going to use charts, plotting the charts. So first, let me show you the dataset which I have. So this one is the CSV file data set. So you can see that these are the months, and these are the mean wave heights that have been recorded for each month. It is 0.81 in the sense it means it is 0.81 meters above the mean sea level. So each value records the wave height that has been recorded for each single month throughout the year, right? So I'm going to use this CSV file for creation of some charts. The next data which I'm going to use is a land use land cover data. So in that data set, let me show you that first. So in the data set, you can see the different categories. You can see the different categories here, and these are the areas that are being represented by each category, and these are the percentages of land area occupied by them. So I'm going to use this dataset also, and this dataset is saved as an Excel file, while the wave height data is saved as a CSV file. So first, let us know how to import the data into the R software, and then we will delve further on the creation of charts using those imported datasets. So the first dataset which we are going to import is the CSV dataset, which is the monthly wave height data. So we're going to use the dataset to create charts. So for that, first you have to create a data frame. So a data frame is nothing but a table. Okay, it is a table that stores the dataset which we are going to import. So in this case, we're going to import this wave height data. So this wave height data will be stored inside a new data frame which we are going to create now. So let me name this new data frame as data, right? So it is data is equal to data space arrow hyphen space. So it will be read.csv of file dot choose. So instead of just typing a whole syntax, you can just autofill it using the tab command. So in this case, I'm going to use this file dot choose command. So I'm just going to scroll down to that, and then I'm just going to press the tab button. So it will be just autofilling it. Okay, so first of all, I'm going to execute only this line of code. As soon as you do that, you'll be getting a prompt like this, which will be asking you to input the data set. So I have saved the data set as annual data.csv in the desktop. So I'm going to just import that file inside this software. So click on open. So in case if you want to check whether it has been properly imported or not, you just have to go to this statement. So it will be head open bracket the data from which you have just created. So if you just execute it, you can see that it will be displayed in the R console beneath this page. You can see the values here, right? So now we have successfully imported the data set into the software. So we're going to use this data to create the charts. So first let us create the bar plot. Okay, so its syntax goes like this. So it will be bar plot. So in case if you're not aware of the syntax or the parameters that are required to create a bar chart, you can just you have to just enter a question mark before that command, and then press Ctrl plus Enter. So by doing that, you'll be getting the entire help functions of this bar plot. You can see that you can see the various syntax statements. You can see the various parameters it requires to create a successful bar plot. So in this case, I'm going to go with this bar plot syntax. So first, I have to input the variable which I'm going to use for plotting this chart. So for that, I have to include the data frame's name here first. So it will be data. Since I have stored the data frame as data, I'm going to import that data frame inside this. So it will be data, and then I'm going to fetch the field of this particular data set. So in this case, so for that I have to use this dollar symbol. As soon as I write that, you can see the field names which are being displayed inside this data frame. So we're going to plot this bar chart based on the value field because this value field represents the mean wave height for each month. I'm going to use that field here. Should I press Ctrl plus Enter, you can see the bars are being plotted here. You can see the result here. Analyze this chart further by giving the labels for the x and y axis, colors for these different bars, title for this chart, etc. We're going to do them one by one. So first, let us label them on the x-axis. Since these bars represent the monthly data, so these bars should be getting the values of the months. So for that, we're going to include the label here by using this statement. So it will be comma space names is equal to names is equal to data frame's name again. So it will be data dollar. Now we're going to fetch the values in the months field, right? So for that we're going to fetch the value of this field. So it will be names is equal to data dollar month, and you have to just close the parenthesis. And if I press Ctrl plus Enter, you'll be able to see the difference on the bar chart here. You can see that the labels are being plotted for the x-axis. So now we're going to give the names for these two different axes. Let's say we're going to name the x-axis as months and the y-axis as wave height in meters. So for that we're going to use the xlab and the ylab commands. So first we're going to name the x-axis. So for that it will be xlab. Xlab in a sense it means x label. So it will be xlab is equal to open double quotes months. For y-axis, I'm going to give the name as wave height in meters. So it will be ylab is equal to open quotes wave height in meters. So if you press Ctrl plus Enter, you can see the labels being written on both those axes. Now we are going to colorize the bars here. So for that we are going to give some colors for these bars. So as far as the R software is concerned, each color is codified to a particular number. Say for instance, 1 is assigned to a particular color, 2 is assigned to a different color, and so on. So these colors are codified to different numbers. We're going to access the colors by referring their numbers. So for that, just press comma again. So it will be call. Call stands for colors. So it will be call is equal to C of. Let's say in this case I'm going to give 4 different colors. So in that case, let's say for instance it will be 2, 5, 7, 9. So these numbers represent 4 different colors. I'm going to use these colors to stylize my bars into different colors. So if you press Ctrl plus Enter, you can see the difference. So the final thing is I'm going to give a title for this chart. So for that I'm going to use the main command. So the main is equal to monthly wave height chart. So should I press Ctrl plus Enter, you can see the difference in the chart here. So with this you have completed a bar chart diagram. So now let's see how to create a dot chart. So for that we want to use the same data set. So let me create a dot chart for this mean wave height data. So it will be dot chart, open bracket, data frame's name, dollar. I'm going to use the value field. So should I press Ctrl plus Enter, you can see the dot chart being generated here. It is a very basic plot which we have generated here. So you can further embellish this by using the labels code. So with this labels code, we can just label out the y-axis using the months field, right? So for that, you have to just include the labels is equal to data dollar months. You get it now. It's being entered now. You can also further stylize the chart by changing the plotting symbol. And just as we saw earlier, each symbol is codified to a particular number. So you can just play around with the symbols by changing the numbers. So for that you have to use this statement. So it will be PCH. So PCS stands for plotting character. So really PCS is equal to, let's say if I give the number as 18, we can see a change in the symbol here. So the press Ctrl plus enter, you can see that it has been changed to a different symbol, right? So you can also colorize these symbols by using the color statement. So it will be color is equal to, let's say I'm going to give the color as blue. So if we give the color as blue, you can see that it has been colored like this. You can also colorize the lines that are running behind the symbols. L color command. L color stands for line color. So let's say if I give the color as red, you can see that it has been changed to red. So now let's move on to the pie chart. So for this chart, I'm going to use a different data set. As I previously discussed, I'm going to use the LULC data set based on the percentage of land cover occupied by each category. We're going to classify the pie chart into different slices. So for that, let's see how to import that Excel file first. So for that, first you have to install a package called Read Excel. So first you have to do that. Only after doing that you'll be able to import an Excel file. But in the case of a CSV file, it is not required. You can just directly import it using the given statement. So you have to type this statement here. So it will be install dot packages. So inside that parenthesis, you have to open a pair of single quotes. So it will be read Excel, right? After this, you have to press Ctrl plus Enter. So as soon as you do that, you will be seeing some prompts in the console window. It will be installing the packages for you. It has been installed. As soon as you install the package, now we have to access the library of that package. So for that, we have to use this command. So it is library, open parenthesis again. So it will be read Excel. So first you have to install the package, and then you have to fetch the package, fetch the tools of the package using the library command. So now it has been fetched. So now we have to create a new variable. Let's say I'm going to create a new data frame. Let's say I'm going to create a data frame as data 1, right? So I'm going to assign this, I'm going to import the Excel file into this newly created data frame. This is data 1, right? So it will be space, arrow, hyphen. So it will be read.excel, right? So it will be read.excel. Inside that, you have to write this file.choose, and then you have to press Ctrl plus Enter. So you'll be getting a prompt, right? So in this case, I'm going to choose the LULC Excel file, right? So it is saved somewhere here. It's here. So I'm going to import the Excel file. Okay. So it has been imported. You can also cross check it by using this command here. So it will be head, open parenthesis, data 1, which should display the LULC file which we have created. So if you just press Ctrl plus Enter, you can see the result here. This particular table is called a table. As you can see, it has been mentioned table. So the main difference, only difference between a data frame and a table is that this table stores the data as well as its type. It is called a table. If it stores only the data, it is called a data frame, right? So that is the difference between a data frame and a table. So now that I have imported the Excel file, I'm going to use the data set to create a pie chart. So for that, I'm going to use this pie charts syntax here. So it will be pie, open bracket. So first you have to input the data. So it will be data one dollar. So as I already said, I'm going to access the percent field of this table. So only based on the percent values, I'm going to classify the data into different slices, right? So I'm going to use the percent field here. So if I just press Ctrl plus Enter, you can see the pie chart being generated. You can see that it has been generated here, but it is so simple. You can also add some more thing to this to make it a bit more attractive. So for that, I'm going to use the labels statement here, right? So it will be labels is equal to data 1 Data 1 is the newly created data frame, also called as a table. So data 1 dollar of class name. So I'm going to label these using my class name. So if I press Ctrl+ Enter, you can see the difference in the pie chart being generated. So now let's say if we want to change the color of this pie chart, you can also do that. For that, just press comma space call is equal to, let's say I'm going to use a rainbow color, open parenthesis. So inside this rainbow syntax, you have to include the total number of colors you want. So in this case, I'm having a total of say 7 categories here. So I have to include number 7 here because each category will be taking a unique color. So you can see the difference here. It has been named so, right? So in case if you want to label these slices based on the percentage value, we have to do some more editing, right? So for that, first let me create a new label, right? So I'm going to create a new variable called new labels. Okay. So this new labels, inside this new labels, I'm going to use the paste function. So it will be paste, open parenthesis. So first I'm going to add the class name. So for that I have to access the table again. So it will be data 1 dollar of the class name, comma. I'm going to use the append tool here. So I'm going to just give a hyphen here, right? So first I've included the class name and then I'm going to give a hyphen here. So that it will be like this: class name followed by hyphen followed by the percentage value. Okay, so we are aiming for getting a label like that. So it will be a class name, comma, hyphen, comma. So now we have to include the percentage value. So for that I have to access the table again. So it will be data 1 dollar of that percentage, right? So it will be class name hyphen percentage, comma. I'm going to include the percentage symbol here. So it will be percentage symbol, comma. I have to include the separator. So this is the final parameter which this syntax requires. So it will be separator. So it will be set is equal to 2 quotes. Okay, so this will be separating the values from each other, right? So we're going to execute this line first, right? It has been done. So now we're going to incorporate this new labels variable inside this by syntax. I'm just going to replace this word with the new labels, right? So this will be creating a new pie chart with the newly defined labels. So it will be new labels. So if I just execute this particular line, so we'll be getting an output like this. As you can see that the decimal points are way too larger for each and every label. So now we have to just round out these percentage values, right? So for that we want to use another function here. So for that first we have to create a new variable again. So let's say I'm going to create a new variable like this. First is equal to round of table's name dollar data 1 dollar the percentage, right? So this particular line will be rounding out the values that are stored inside the percentage field name. I'm going to first execute this and then I'm going to use this inside my syntax, right? For that, instead of this word, I'm going to replace this with the newly created variable. So it will be like this. So you can see the result if you execute this particular line. So you can see the result being displayed there. So for all those values are rounded to single digit numbers, rounded to without any decimal. Right? In case if you wish to create a 3-dimensional pie chart, it can also be done You have to just install a package called the Plotrix package. First, let me install that package. So it will be like this. Same thing again. So it will be installed at packages. So it will be Plotrix package. We are going to install the Plotrix package. So you press Ctrl plus Enter. It will be installing the package. So you have to access the library of that package. After this, the library Plotrix. So now, since we have added the, since you've installed the package, it is very simple to create a three-dimensional chart, three-dimensional pie chart. So all you have to do that is that you have to just include a three-dimensional. You have to just include the word 3D here after the pie. So it will be 3D. You can see the chart generated here. So now let's see how to create a histogram. So for that, I'm going to use this command again. So it will be hist data frame 1, right? So I'm going to use the first data frame which you have created. So it will be data dollar of the month. You can see the result. You can see that the 1.1, 1.1, 1.2 are the most frequently occurring values in the entire data set. This by using colorize this by using the same step again. So it will be call is equal to, let's say call is equal to let. Let's see how to create a scatter plot. Okay, so for that we have to include the statement. So it will be plot. I'm going to use the first data set again here. So it will be data value. I'm going to use the second variable as well. So it will be data dollar months, right? The result. So you can see the result here. So the dot chart and a plot are both nearly similar, with the only difference being the second variable which is being recorded as a quantitative variable here, whereas in the case of a dot chart, it has been given as a qualitative variable in the form of a label. So the final chart which we are going to see in this tutorial is the box plot. So first of all, let us understand what a box plot means. So a box plot is basically used to depict how well the data is clustered or dispersed. Okay, so it is a measure of the dispersion of data points inside a data set. So we're going to generate a box plot for our monthly verified data set. So let me write the statement for the box plot. So it will be box plot the data frame dollar of that value. So let's say I'm going to give the color as green. So you can see green color here. So you can see that the box plot is being generated here. So what it means is that a box plot is divided into four different zones. So this first zone is called the first quartile range. This one is called the second quartile range. This one is the third quartile, and the final one is the fourth quartile range. So this line is called the median line. So this median line will be separating the second and the third quartile ranges. So as you can see in this data, this median line is slightly favoring towards the higher positive values, which means that this data set is positively skewed, which means that the data points in this data set are slightly leaning towards the larger values as compared to the smaller positive values. So with this, we have learned how to plot some basic charts using some basic data sets. So I hope this video was of some use to you. Please do keep tabs on this playlist for many more interesting geospatial contents. So thank you so much for watching.